Still in calculus, integration, definite integral and indefinite integral. So today we are going to see the indefinite integral. First of all, we have to know what is integration. What do we mean by integral? So integral it is just a reverse of what? Reverse of differentiation, because in differentiation we said n of x to n to -1. Whenever you find x, you are going to find the x power n is the same thing as you have to keep the power of n down and you have to write the function here, and therefore you have to put your n and then subtract by 1. So in integration we are going to say x raised to the n plus 1. If I have x to the power of n, so this will be, I have to put the n, so already I have the power, so I have to add it by 1. If I add by 1, then I have to divide it by what? By n plus 1. So I have to say n plus 1. So this is integration. So we said integral is what? It's a reverse of differentiation. So let's say suppose we have x squared. Differentiate this. If I'm going to differentiate it, I'll keep the 2 down, I'll put x, then I'll subtract by 1, I'll have 1. So this is the same thing as 2x. So let me say integrate this. If I am to integrate x squared, this should now be equals to what? Should now be equals to x2. I have to add 1 here, then I have to divide it by what? I have to divide by 2 plus 1. So this should now be equals to what? X to the power of 3 by 3. I hope you get it. So this is what? I integrate x squared, but here I differentiate x squared. The difference is that in differentiation we are subtracting it by 1, we are not dividing, but in integration we are going to divide the n and the 1 that we add. So therefore we have to divide by n plus 1. As you can see here, n plus 1, which is our n, which is 2 plus 1. So therefore this is the same thing as saying 1 over 3 of what? X what? X cubed. So suppose if I'm asked to differentiate this, I'll say 1 over 3 multiplied by, I have to say 3x what? X squared. So this 3 will go with the 3. At the end I'll get my x squared. So this is showing you that integration is a reverse of differentiation. So after finding this, so when you differentiate it again, still you're going to get your final result as what? As x squared. And if you integrate this again, you will get this. If you differentiate this again, you will get back to what? To this. So this is the difference between integration and what? And differentiation. So you have to take note with this. X power n is the same thing as x to n plus 1 over n plus 1. So first I'm giving an example. Differentiate x squared plus 5x plus x dx. So guys, if I'm asked to integrate this, the first thing that I'm going to do, I have to say the integral of what? X squared plus the integral of this 5x plus the integral of x, all it has dx. So because this dx, it contains with this, and it carries this, and it carries what? This. So I can write it as x squared dx. So let me first integrate this. If I integrate this, I will have what? X squared. I have to add 1, then I have to divide by 2 plus 1, which is equals to x cubed by 3, or you can write it as 1 over 3 x cubed. And then I have to integrate 5x dx. This is the same thing as factoring 5 out, and I have x. The next thing to do is that I have to say I have only x, the power which is 1, so I have to say 1 plus 1 over the power 1 plus 1, which is 2. So this should now be equals to x squared over 2. And don't forget I have 5, so this should now be equals to 5x squared by 2. I can say 5 over 2 x squared. Then I have to integrate value of x. To integrate x dx is the same thing as what? X squared over what? So let's check it and see. Integrate x. This is the power of 1. I have to add 1. I have to divide it by what? By 2. Because 1 plus 1 is 2. This should now be equals to x squared by 2. So this is the same thing as 1 over 2 x squared. So at the end, the final solution for this, it should now be equals to integration of this. I have, let's say, x cubed by 3 plus 5x squared by what? By 2. And therefore I have to say plus integration of x, which is x squared by what? By 2. And then I have to say plus constant. Whenever you come across indefinite integral, after integration, so you have to say plus constant x, plus x. So we said integration is a reverse of differentiation. The first thing that I'm going to do to check that is that I have to differentiate this. 1 over 3 x cubed. Let me differentiate this. This should now be, if I keep this aside, I will have 1 over 3, then I will differentiate this. I will have 3x squared. This will go with this. At the end, I'm left with x squared. As you can see, this place we have x squared. So let's verify this. We have 5 over 2 and we have x squared. So let's keep this 5 over 2 aside and differentiate x squared, which is 2x. After then, this 2 will go with this 2. At the end, I will left with 5x. So we verify this 5x, and therefore let's verify this x squared. X squared over 2 is the same thing as 1 over 2 of what? X squared. 1 over 2, differentiate this, I'll get 2x. 2 will go with 2, x times 1, which is equals to x. So guys, I verified this. As I said, integration is a reverse of differentiation. So let's see another example. So let's see the second question. Suppose we have the integral of x power 5 plus x raised to the power of what? 10 plus x raised to the power of 3 dx. So how can I integrate this? The first thing I will integrate, I will say x 5 plus 1 over 5 plus 1 plus x, I will add 1, 10. We should add 1 according to this formula, because I have x raised to the power of n and x raised to the power of 10. Then I will say the x, I have to add 1 here, add 1, then divide by 10 again, plus 1, and then plus x. This is x raised to the power of 3, add 1. If you add 1, divide it by the whole. which is divided by the power, which is 3 plus 1, and then you have to add plus constant. This is the same thing as saying x raised to the power of 6 over 6 plus x raised to the power of 11 over 11 plus x raised to the power of what? 4 over 4 plus constants. So this is the final solution to this problem. So how can we verify it and check whether we are right or wrong, or whether we are going to get the reverse? Integration is the reverse of differentiation. So let's differentiate whether we are going to get back the final result, the question that we are given. So I have one, or this is the same thing as saying 1 over 6 of x to the power of 6. So I have to keep this aside, 1 over 6. Then I have to differentiate this. I'll get 6 what? 6x raised to the power of 5. This will go with this. At the end, I'll find x raised to the power of 5. Yes, it's verified. We get x raised to the power of 5. So, and then I have x 1 over, this is the same thing as writing 1 over 11 multiplied by x raised to the power of 11. So, after then, keep this aside, 1 over 11 aside, then differentiate this 11. I'll have 11x raised to the power of what? 10. After subtracting it by 1, we are differentiating. So therefore at the end 11 will cancel 11. At the end x raised to the power of 10. So we find s raised to the power of 10. We verified it. Again, we have to pick this. This is the same thing as 1 over 4, and we have x raised to the power of 4, and then I have to keep 1 over 4 aside. I have to differentiate this. I'll get 4x cubed, then 4 will go with 4. At the end, x raised to the power of 30. So therefore, I verified it. I get x raised to the power of 30. So let's see the integral of 2x plus 1 dx. 2x plus 1 dx, this should now be equal to, if I integrate this, I will have 2x. First, I will keep the 2x, then the power, which is 1, I have to add 1, I have to divide by this, 1 plus 1, according to this formula. So I have to say plus, I have 1 here. So the next thing that I'm going to do, in differentiation, derivative of constant, it is 0, but in integration, integral of a constant 1, it is x. Why is it x? It is x if you are integrating with respect to x, and it will be y if you are integrating with respect to y. It will be z if you are integrating with respect to z. As I am integrating with respect to x, the integral of this constant will now be only x. And therefore, if I am integrating with respect to z, the integral of a constant, it will be that z. If I am integrating with respect to u, the integral of that constant will be only u. So the integral of this constant will be x. So this should now be equal to 2x squared by 2 plus x plus constant. So therefore this 2 will go with this 2. At the end, I'll have x squared plus x plus c as the final solution. So how can I get back to the question to check whether I'm right or wrong? By using the differentiation. If I differentiate x squared, I'll get 2x plus, if I differentiate x, I'll get 1. So therefore, this is my result. It means I am correct. So let's say we have integral of 1 over x. Integral of 1 over x, it is what? Ln x plus c. So this is the final solution to this constant. Whenever you are going to integrate 1 over x, so it's the same thing as ln x. So how can this ln x change back to this? If I differentiate ln of x is the same thing as 1 over x, so therefore it turns back to this. So guys, this is all about the introduction to indefinite integral. If this video is more helpful to you, kindly consider subscribing so that you will be notified immediately if I uploaded a new content. Don't forget to like, comment and share to your learning colleagues. Have a nice day.